In 11.7, starting on page 627, we begin talking about infinite geometric series. So the infinite part of this section really is telling us that we just keep adding terms and that we have more and more terms that we are adding to our sequence. So there are a couple of different problems that we are going to discuss, the first of which I'm actually trying to find the sum of the series, and here is the formula for that. So I can find the sum of a given series if the common ratio that I find, the absolute value of the common ratio, is less than 1. For example, if my common ratio is 1/2, so an example of that, let's go ahead and say I start at 4 and the common ratio is 1/2. That means my next term would be 2, and then my next term would be 1, then my next term would be 1/2, and then 1/4, so on and so forth. So if my common ratio, the absolute value, is less than 1, which it is, then I can go ahead and plug in my information into this formula and find what number that series actually approaches when I'm adding every single term all the way up to infinity. So for example, the sum of the entire series, so every single term all the way up to infinity, a sub 1, which is 4, over 1 minus r, which is 1/2. So that is 4 divided by 1/2, and that's going to equal 8. So the sum of the entire series, even if I do 50 terms or 100 terms, it's going to keep getting closer and closer and closer to adding to 8. Alright, there are a couple other examples where this wouldn't work out. For example, if the absolute value of r is greater than 1, so let's say r is equal to 6. If r is equal to 6, that means, an example right here, let's say I start with 1, that means I'm multiplying by 6 every single time. So I get 6, and then 36, and then 3 times 6 is 6 carry the 3, 216, so on and so forth. That means the sum keeps getting bigger and bigger and bigger and bigger because I'm adding bigger and bigger numbers. So this one approaches infinity. That's why there is no sum, because it just keeps getting bigger, so it actually approaches infinity instead of a solid number. Alright, so let's look at a graphing example for a sum. So this would be number 1 on your packet. 1 plus 1/2 plus 1/4 plus 1/8. Alright, so given a graph, I'm looking at S sub 1 and S sub 2, S sub 3. So that means I'm adding 1 term, I'm adding 2 terms together, 3 terms. So if I were to do my XY chart, 1 term, 2 terms, 3 terms, 4 terms. So if I just had 1 term, that means my Y value is 1. If I were adding 2 terms, that's 1 plus 1/2, or 3/2. If I were adding 3 terms, that's 1 plus 1/2 plus 1/4, which is actually going to give me 1.75. If I were to add, so for my 4th term here, I would actually add all 4 of these terms together, and I would probably get a decimal and approximate the graph here. So at 1, my point is 1. At 2, my point is 1.5. At 3, it's 1.75. And so I know that it keeps getting closer and closer to a number, so a total sum. So here, I can actually use my formula, a sub 1 over 1 minus r. I know that r here, what am I multiplying every single time by? I'm multiplying it by 1/2, so r equals 1/2, and my first term is 1, so 1 minus 1/2. Alright, so that's 1 over 1/2, which equals 2. So that means it's going to keep approaching this 2 right here as I add more and more terms, but it will never actually get there. And that sums up the graphing part of 11.7. Now I can actually do a couple examples of, alright, can I actually find the sum? So can I use this formula? So a sub 1 over 1 minus r. Can you use it or not? So you need to be looking at your ratios. This is a sub 1 equals 5 and r equals 1/2. So looking at my ratio, that is less than 1, so I can use it. So then you plug it in and find your sum. So s equals a sub 1 is 5 over 1 minus 1/2, 5 over 1/2, that equals 10. And another example, this is number 9 on your packet. A sub 1 equals 1, r equals 5/2. Alright, I need to look at my ratio, and that is actually greater than 1, so that means there's no sum. It approaches infinity. It just keeps getting bigger and bigger and bigger. So I don't even need to use this formula. You can just tell me no, not possible. There will be no sum. Alright, and that sums up 11.7.